Good morning, class. For today's class, we will be discussing on illustrating linear equations in two variables. We will be having our learning objectives. Number 1, illustrate linear equations in two variables. Number 2, construct a table of values for x and y given a linear equations. And number 3, determine the solutions of linear equations in two variables using one of the ICT tools. So let's have first the definition. We have forms of linear equations in two variables: the standard form, the slope-intercept form, and the point-slope form. First, standard form, ax plus by plus c equals 0, where a and b are the coefficients and c stands for constant. For example, 3x plus 2y minus 11 equals 0, where the coefficients are 3 and positive 2, then the constant is negative 11. For the slope-intercept form, y equals mx plus b. M here is the slope and b is the y-intercept. For example, y equals 3 over 2x minus 3. The slope here is 3 over 2 and the y-intercept is negative 3. For the point-slope form, y minus y sub 1 equals m multiplied by x minus x sub 1, close and open parentheses, where m is the slope, x sub 1 and y sub 1 a point on the line. For example, y minus 3 equals 3 multiplied by open parentheses x minus 4, close parentheses. The definition. Linear equation in two variables is defined as an equation if it is written in the form of ax plus by plus c equals 0. Again, linear equations in two variables is defined if it is written in the form of ax plus by plus z equals 0, where a, b, and c are real numbers and the coefficients of x and y, either a and b respectively, are not equal to 0. For example, 10x plus 4y equals 3 and negative x plus 5y equals 2 are linear equations in two variables. The solution for such an equation is a pair of values, one for x and one for y, which further makes the two sides of an equation equal. Solutions of linear equations in two variables. The solution of linear equations in two variables, ax plus by equals c, is a particular point in the graph, respectively, or we're talking here the Cartesian plane, such that when x coordinate is multiplied by a and y coordinate is multiplied by b, then the sum of these two variables will be equal to c. Basically, for linear equations in two variables, there are infinitely many solutions, meaning there are so many solutions for some of the linear equations in two variables. Example, in order to find the solution of linear equations in two variables, two equations should be known to us. Consider, for instance, 5x plus 3y equals 30. The above equation has two variables, namely x and y. Graphically, this equation can be represented by substituting the variables to 0. The value of x when y equals 0 is, so we need to substitute y by 0. So it will become 5x plus 3 multiplied by 0 equals 30. So 5x plus 0 equals 30. So we need to find the value of x. Therefore, we need to distribute or transfer 5 to the other side, or we need to divide to cancel out 5 and x in order to x to be left on the other side. So it will become 5x over 5 cancelled out 5, so there is only x being left, equals 30 divided by 5 equals 6. So the value of x here is 6, while the value of y is 0. And the value of y when x equals 0 is 5 multiplied by 0, because we substituted x by 0, plus 3y equals 30. So 5 times 0 equals 0, so the remaining equation is 3y equals 30. So divided by, or to cancel out 3 in y side, so y equals 10. We have here a table of the types of solutions and their graphs. So we have first the unique solution, a consistent and independent. We have also the no solution, inconsistent and independent. And the last, infinite number of solutions, meaning there are many solutions for such equation. It is considered also as consistent and dependent. So the conditions for unique solution, a sub 1 over a sub 2 is not equal to b sub 1 over b sub 2. And the conditions for no solution is a sub 1 over a sub 2 equals b sub 1 over b sub 2 is not equal to c sub 1 over c sub 2. Then the conditions for infinite number of solution is a sub 1 over a sub 2 is equal to b sub 1 over b sub 2 is also equal to c sub 1 over c sub 2. System of linear equations in two variables. Instead of finding a solution for a single linear equations in two variables, we can take two sets of linear equations in both having two variables in them and find the solutions. So basically, the system of linear equation is defined when there is more than one linear equation. For example, a plus b equals 15 and a minus b equals 5 are the system of linear equations in two variables. Because the point a equals 10 and b equals 5 is the solution for both equations, such as a plus b. Replace the value of a by 10 and the value of b by 5. So it will become 10 plus 5 equals 15. So it is true. So then a minus b equals 10 minus 5 equals 5. It is also true. Hence, prove point 10, 5 is solution for both a plus b equals 15 and a minus b equals 5. So we have here a table of a linear equations in two variables in the form of ax plus by equals c, or in the standard form. So let's only take the number one example. 4x minus 5y equals negative 7. So as what I have said, x and y represents the coefficients of the equation and the c represents the constant of the equation. So for the example number 1, 4x minus 5y equals negative 7, the coefficients of the equation here are 4 and negative 5, while the constant of the equation here is the negative 7. Next is for the form slope-intercept form, or y equals mx plus b. Let's have example number 3, y equals 5x minus 10. So the slope here is positive 5, while the y-intercept here is negative 10. So problem and solutions. For questions number 1 example, find the value of variables which satisfies the following equation. 2x plus 5y equals 20 and 3x plus 6y equals 12. Using the methods of substitution to solve the pair of linear equations, we have 2x plus 5y equals 20 and 3x plus 6y equals 12. So multiplying equation by 3 and equation number 1 by 3 and equation number 2 by 2, we have 6x plus 15y equals 60. And for the equation number 2, it will become 6x plus 12y equals 24. Subtracting the second equation from the first equation. So therefore, it will become 3y equals 36, y is equal to 12. Then substituting the value of y in any of the equation from the first or the second, we have 2x plus 5. Substituting the value of y becomes 12, so it will become 5 times 12 is equal to 60. Then the value of x, if the value of y is 12, is negative 20. Therefore, x equals to negative 20 and y equals 12 is the point where the given equation intersect. Now, it is important to know the situational example, which are also known as word problems from linear equations in two variables. So we have here one word problem. A boat running upstream takes 6 hours 30 minutes to cover a certain distance, while it takes 3 hours to cover the same distance running downstream. So what is the ratio between the speed of the boat and speed of the water current, respectively? So we have the solution for the given word problem. If the speed downstream is kilometer per hour and the speed upstream is kilometer per hour, then speed in still water is equal to a plus b divided by 2 kilometer per hour, while the rate of stream is equal to 1/2 multiplied by a minus b kilometer per hour. Let the boat's rate upstream be x kilometer per hour and let the downstream be y kilometer per hour. Then distance covered upstream in 6 hours 30 minutes is equal to distance covered downstream in 3 hours. So we have x multiplied by 6.5 hours equals y multiplied by 3 hours. So it will become 13 over 2x equals 3y. Then y equals 13x over 6. So the ratio here is, or the ratio between the speed of the boat and the speed of the water is equal to 19:7. So in order to know if you have learned something from our lesson for today, I will be giving you learning activities. For the activity 1, feel what is missing. Part A, you just need to identify the coefficient for the given linear equation in standard form. So we have 5 items. And for the part B, you still need to identify where or what is the slope and y-intercept of the given linear equations in slope-intercept form. And lastly, I have given you an assessment. So a real-life problem or a word problem. A boat running downstream covers a distance of 20 kilometers in 2 hours, while for covering the same distance upstream, it takes 5 hours. What is the speed of the boat in still water? So you need to apply what I have given you or explained to you in how in getting the real world from using a two variable or a linear equations in two variables. Then for the points for this assessment activity, I will be giving you 20 points for all if you will be presenting me the right solution with answer with the correct explanation. And lastly, write your thoughts, comments, or suggestions for this lesson. If you have any suggestions that you can give to me. And that would be all of our class for today. Thank you and goodbye.